Okay, so the problem is number 91, Decode Ways. You have intercepted a secret message encoded as a string of numbers. The message is decoded via the following mapping. 1 will be A, 2 will be B. Okay. However, while decoding the message, you realize that there are many different ways you can decode the message because some codes contained in other codes. Okay, like 2 and 5 vs 225. Okay, so AAJF with the grouping 1 1 10 6 or 1 1 10 okay 11 10 6. Okay, so we cannot have leading zeros. And there will be strings that are impossible to decode. So given a string as containing only digits, return the number of ways to decode it. If the entire string cannot be decoded in any valid way, return 0. Okay, so so if any of the code is invalid, then it will be an invalid decoding. So for a valid decode, you have to make sure that every group is valid. Okay. So if we have 0 1, if we have 0 1, then it is invalid, we will return 0. But if we have 108, then we can have 10 8, and it is we can have 10 8. Okay, there are no other options, so we'll have 1. Okay, so does it only contain digits like 0 to 9? Okay. Okay, then it will be at least 1. So this will be 0 as well, because it is invalid. So let's begin our solution. So yeah, because I'm thinking of if you look at the last digit, if we select it to decode, then the problem will become if the rest of the array, the rest of the string is valid to decode. So yeah, it will be a dynamic programming problem because the problem is the same, but the size of the problem shrinks. So I will first use a depth first search approach to do a recursion. Okay. So let's set if like if Si can be decoded, then the problem shrinks to S 0 to Si minus 1. That is Si and yes, and we can say we can also, there is another option, like if Si till like can be decoded, sorry, I will write it like this: if Si minus 1 till Si can be decoded, then the problem shrinks to S0 till Si minus 2. So in this case, it will be Si minus 1. Yeah, there are two options to choose, and we want to like we want to get the number of ways to decode it. So if this can be decoded, then number of ways will be added 1, and the problem shrinks to smaller. If this can also be done, then yeah, and number of ways should be 1 as well, should add it by 1. Okay, that's define DFS. So if DFSI is meaning the number of ways that S0 to Si can be decoded. So DFSI will be yeah, like there are two options. So let's talk about the boundaries. So if I is smaller than 0, then there will be no digits to select to see if it can be decoded. So it will be 0. Okay, and then so to implement, if I is smaller than 0, return 0. And now, since we are now at the boundaries, if si let's say if si is not equal to 0, like we are now implementing the first condition. So if the first option, if si is not equal to 0, then it can be decoded since it has only one digit. Okay, and the rest of the problem is valid, so it will be DFS I minus 1. We have ways here is 0. Then if si is not 0, we are now implementing the second option, and as I minus 1 is smaller than 7. Oh no, like more than 7, and this is smaller than 3 but larger than 0. Okay, then and the rest of the DFS I minus 2 like yeah, if the rest of the array can be decoded, and what does it mean for can be decoded? Like the number of ways will be like number of ways will be larger than 0. But what if this is the last element, like si is 0? If si is 0, then if si is 0, as this will be DFS -1, so it will return 0, and we will not go into this condition, but we should return 1. So or if this is 1, then we will pass. We'll pass like if DFS if DFSI is 0, then if I is 0, then SI is not equal to 0. If it's -1, it will have 1. So like the ways will become 1. And since we should have I larger than 0. Or we can have like if I is no. Okay, then if this is 1 and we have like 26, it is I will be 6 and 0 is 2, so this is correct, and DFSI will be -1 and it will return 1, so we will have ways plus 1. So like we have 26 for 6, sorry, yeah, for 6 it will have 0, yes, -1, 1. But we haven't added like the ways before. Yeah, for example, we have the entrance of the recursion will be dfs_n. Oh no, sorry, dfs_n minus 1, and n will be the length of the s. Oh, since si, okay, I will have this, and okay, I should change the digits to string. Let's have to do. But yeah, like the first thing, like we haven't added up the return ways for the rest of the array. So yeah, if it is zero, it should be 0, since we don't want, if I is 0, we don't I think I would like to try like 92. Okay, if 92, then n is 2, so it will be dfs_1. So for dfs_1, if s1 at 1 is 2, and that's C, dfs_0. For dfs_0, like I think we have to do something like this, but okay, we will just stay with this. We'll have yeah, we'll have to talk about the boundaries. Or no, okay, for 92, let's try run and see like which part we should change. So DFS1 and S1 is not 0, this is 2, so we will see DFS0. DFS0 will not enter this condition. S0 is not 0, so it's 9, and we will see so we don't have to check like if okay, so we'll have if like only if I is larger than 0, we have to check this. So okay, I'll write it here. If I is larger than 0 and like this. Like how many ways? No. Oh, we should not add 1. Like since we are calculating the yeah, like this, we should return 2. Like we can do 9 2 separately, and we it's only 1. We should do it separately. So when we have an empty array, we should return 1. But if then we should not add 1 here. I think it will be like this. Like if it is an empty array, then we can have 1 because yeah, like you have finished counting like a partitioning. So it is 1. And if so, that's C. Okay, I think let's change it. So if SI is okay, SI should not be equal to 8 or 7. Like the second digit cannot be 7, 8, or 9, and the first digit you can only be can I write it like this? I'm not sure. Like Python set. Oh, you can do it like this. Okay, then I will have we can only have 1, 2. Okay. And SI not in this, but SI minus 1 is in 1 and 2. Okay, so the to-do has finished. Yeah, let's see if 92 makes 1. So now it's 2, DFSI is 1. If S1 not equal to 0, correct. It's 2 is not a 0, so the ways 0 at default will have to count let's say I think it is like there are two options, like there are two ways, and yeah, like I want to sum up these two ways. So okay, so DFS, now we have I is 1, so it is DFS 0, so DFS 0, I is 0, S0 at 0 is 9, and DFS 0 minus 1 is -1, and it returns 1. So for this we will got 1 and yeah, so ways will be 1, and for this as I is 1, we are now in the outer stack of the recursion. So if I is larger than 1, but as I is not 7, 8, 9, but Si is not in 1 and 2, so we will not be here, so ways will be 1. Yeah, and that's C 26. So for 26, and will be 2 as well. So DFS 1. For DFS 1, it is not S1 is not 0, so we will have DFS 0, and for DFS 0, so we will have 0. DFS 0, S0 is 2, so we will have DFS -1, and it returns 1. So ways will be 1, and let's see. I is larger than yeah, like I is 1 now, and yeah, both of them met the condition, so we will check 1 minus 2 is -1, so it will return 1 as well. Then we will have 2 for the ways. Okay, let's see. Okay. Oh, we should add it like a catch. Else maybe it will time out. Oh. I'm thinking, I think we should still have this check, because it is not only added up like how many, like yeah, if the rest of it is 0, then there's no, like, we will add it up. I'm not quite sure, since yeah, like if 92, it will be, yeah, if we have 1 here, then the rest of it is 0, it's okay. Or if we have, like, let's say if 0, 5, it should be 0, 5. We already checked it, it's correct. How come it should be like long? It will error. I think we should do a check. Let's see. Okay. Okay, that's back to the definition. So if SI can be decoded like this can be decoded, so the problem will be trying to find if this can be decoded. Okay, so if this can be decoded, trying to find if this can be decoded. Yeah, it seems like a tree thing. Well, if we have like, let's see, like, is it an easier example? Will it be wrong? Why is it? Is that because there is a 9? There are 3, like we can, like maybe we have tested like this. And this one is correct. So 1, we can do it like, let's say 4, 2, 6, 11. We can have 26, 11. No, we should have 26, 1, 10, and 5. So 0 should always be 10. And we can have 2, 6, 1, 10, 5. We can have, and there's only 2. I think the problem is similar to like climbing stairs. Yeah, like you have to reach the last stair, so it is valid. And you can count the way to, like the way can be added up by 1. But if you cannot climb to the last stair, then it is not valid. And you cannot add it, like add ways to by 1. Even though the you can climb some stairs, but as you cannot climb to the last one, you fail. But how come? Okay, let's try. Okay, so for the last 62, it should be separated, like 2, 6, 5, 6, 5, 7. Oh, you can have like you can have 17 or 7 with 1. So you will have this. 7, 9, 5, I have 10. You should always have 10 and 1, 6, 2. Or you can have 26, 1, 10, 5. Okay, then, yeah, it is 4, but why would my solution wrong? If SI can be decoded, the problem will shrink. Like, this can be decoded. The problem will shrink to this. Okay. Yeah, it is like a tree, like if, or we don't use, I think this is not. If SI can be decoded, then the problem will become DFSI minus 1. Yeah. Let's say that's still so let's say if (26, 26), it would have, you can have 2, 6, 2, 6, and you can have 2, 6, 26, 26, you can have 2, 6, 26, or 2, 26, 2, 6. Let's see if like, okay, let's try this one, or we can, let's see if 26 works. So how come? Like if I use this, I'm gonna have 1 in the end. And because I did not add I already add up 2 of these. Let's see, like 2 is here, then it will be like check the rest, and it cannot run here, so okay, so after asking AI, I found the main problem is not the ways. Like this has no problem. It's the digit transformation. This is not correct. Like I have seen somebody do it like this, like as like I minus 1 till I plus 1. And if this is between 26 yeah, I see somebody do it like this, and let's see if this works. Okay. Okay, then since we have a stack, we are using recursion, so that's transformed into a for loop, so that the space will be okay. The time complexity here is O n. Okay, so let's turn it into a for loop. And before having a for loop, we will have we will first have like ways array to keep track of the ways at each, like ending at each I, ending at each index I. So we will have we will have a dummy node, so it will have been 0 and multiplied by n. So for I in range 0, in range n, if if si is not equal to 0, then we will have ways I plus 1 to become ways I. Yeah, like this current answer will become the problem will shrink. Okay, and if I is larger than 0, and let's copy here. And I think this thing for Python is really cool. I will check later on. And yeah, the current ways will be added for I minus 2. Oh, sorry, I minus 1. So then we will return the ways at the end. Okay. Oh, it'll be like this. And